for this
first part, but when we continue to do proofs in our other chapters, I won't give you that list of properties. Okay? So it does pay to try and memorize them. Okay? So it's a lot of new stuff that you have not gone over before in math. Yes. So on Canvas, I didn't post it yet, but I will post that Quizlet with flashcards on all of these properties. So you can go through those, and that will help you with some of this stuff, okay? So off to the left here, I have all of the properties listed out, okay, on each and every page, along with their definition. Okay, what I want to do is kind of go through some examples of what's going on for each property. So the first one we have is addition property of equality. Okay, this usually has to do more with algebra. Okay, so it's adding the same number to both sides of your equation, which keeps that equation equal. So say I have 5x plus 4. Okay, and that is equal to 6x minus 2. Okay, so when I'm solving an equation, usually add a number to both sides to start solving it. So if I were to, let's say, just add on 2 to both sides, okay? You're adding on that same number to both sides. It's the addition property of equality, keeping it equal. For letter B, that's subtraction property of equality. It's the same thing, except you're subtracting on both sides. Okay, so if I have 7x plus 6, okay, that's equal to 4x. Okay, so you could subtract 6 from both sides. Okay, that's not how you would solve this, but you could subtract 6 from both sides, keeping that equation equal. Division, property of equality, okay, same thing. You're keeping your equation equal, except this time you're dividing. So if I have 5x equals 15, and I want to get x by itself, well, I would divide both sides by 5. Okay, so that's where your division property of equality comes in. Multiplication property of equality is multiplying the same number to both sides of the equation. So if I have 1/2 x equals 4. Okay, I could multiply both sides by that reciprocal of that fraction, so 2 over 1. Okay, so that's your multiplication on both sides of your equation, keeping that equation equal, solving for x. Okay, so those are your 4 properties of equality. Okay, equality has to do with keeping your equation equal. Okay, so that's what you should associate that with. The next one is the distributive property. Okay, you've heard this word before. So multiply a single term and 2 more terms inside a set of parentheses. So that one, if I have 3 times the quantity 4x minus 1, okay, you would distribute to both terms. Okay, so I would have 12x minus 3. Okay, or adding together 2 terms with a variable is also considered the distributive property. So if I have 3x plus 2x, okay, as my statement, and I want to combine like terms to get 5x, Okay, that's also considered the distributive property. Okay, so combining like terms with a variable is the distributive property. Letter F is substitution. Okay, so you're substituting something else in, or whatever it was. So if I have x equals y, then x can be substituted in for y in any equation, and y can be substituted in for x in any equation. Okay, so if I have x is equal to 7. I know I found x and it's 7. Okay, and I know 3x minus 2. I have this equation, 3x minus 2 for one of my sides of something. I can plug in 7 for x. Okay, so then I know I can take 3 times 7 minus 2. So you're plugging in that value for x. Okay, so whenever you're plugging something else in, that's substitution. You're substituting it in for something else. Any questions on those first couple properties there? All right, letter G is property of opposites. Okay, so it's adding a number to its opposite to create a 0. So if I have any number, A, okay, you want to add its opposite. Okay, so I would add on its opposite. So any number, doesn't matter what number, you add on its opposite. So if I had -4, I would add on its opposite, which would be +4. Okay, that's your property of opposites, where it's going to result in a 0. Your identity of addition is the sum of any number, and 0 is the original number. Okay, so if you take any number, again, I'll just write A, you can write X, it's any number. Okay, and I add on 0. Okay, that number is still itself. Okay, so identity of addition, if you add on 0, it's still that same number. Identity of multiplication is any number multiplied by 1 is that same number. So your identities, you're getting that same number again. Okay, with addition, you're adding on 0, results in the same number. Identity of multiplication, you multiply by 1 to get that same number. So again, if I have A, if I multiply that by 1, it's still going to give me A. Okay, so if I had 4 using a number, if I multiplied it by 1, that would still result in 4. Okay, so any number multiplied by 1 is itself. Okay, next we have definition of subtraction is the taking away of a number from another number or adding the opposite. Okay, so if I have 9, okay, -4, you're taking away a number from another number. It's definition of subtraction. K is the reflexive property. So for every real number x, x will equal x. Okay, so a number equals itself. So again, A equals A, 4 equals 4. Okay, just equals itself. When we get into doing angles and segments, proofs with angles and segments, some of these you will need to write in the reflexive property, such as, I'll just write one. If you have segment AB, okay, it could equal segment AB. So it just equals itself. Yeah.
So like for the test for this, we have to know all these off our head. Like,
not right away. I will eventually, you'll you'll get so used to doing them that it's just going to come to you. But for the first couple, I'll give you these, okay, the ones in bold here. I won't give you the actual definition, but you'll be able to see each of these, okay? After the reflexive property, we have the symmetric property. So for all real numbers x and y, if x equals y, then y equals x, okay? So just reflecting over a mirror, so if a equals b, then b equals a. Okay, you're just reflecting it. Questions on that page? We're going to start getting into more that you don't know right away here. Alright, so the top one is a transitive property. Okay, we're going to use transitive property a lot. So you do need to know what transitive property is. So if I have A is equal to B and B is equal to C, then A will equal C. Okay, so since both of these letters here, A and C, equal B, they must equal each other. Okay, so if I have B is equal to 4, okay, and C is equal to 4, since both of those equal 4, I know B has to equal C, since they equal the same number. Okay, that's the transitive property. Okay, next is the midpoint theorem. Okay, so if M is the midpoint of segment AB, then segment AM is congruent to segment MB. So we did go over midpoint already in chapter 1. Okay, that's one of the first things we went over. So if I have this segment AB and I have a midpoint M, so in the middle we have midpoint M, I know that those two smaller segments are congruent or equal. So AM is congruent to MB, and I can mark those as congruent with that dashed line there. Okay, next is the definition of bisect. So we've kind of dealt with bisect where I said something bisected something else. Bisect means it's splitting it into two equal parts. Okay, so it's splitting it into two congruent parts. So I'll show you that with an angle measure. So if I have an angle here, and I want a ray that bisects that angle, okay, it'll go through the middle. Now if I have angle 1 and angle 2, okay, so I have two angles drawn in there, I could say that those two angles are congruent, and I'll label them with those arcs, okay? So if that ray bisects that angle, I know the measure of angle 1 is equal to the measure of angle 2. Okay, so those two angles would be equal or congruent. That's what bisect does. So if something bisects something else, splits it into two equal parts. Next, we have the supplement theorem. Okay, supplement theorem. So if two angles form a linear pair, then they are supplementary angles. Do you remember what a linear pair is? We went over a linear pair. So if you have a straight line, okay, straight line is 180 degrees, right? If I have a ray that comes off of that line, I have two angles, okay? I can label this angle as 1 and this angle as 2. Okay? If I have a linear pair, this is a linear pair, I know I can take the measure of angle 1 add on the measure of angle 2, and it will be 180. Okay, so yes, they are supplementary, but this is considered the supplement theorem because they are a linear pair. So if it states that you have a linear pair, your reasoning behind saying this would be supplement theorem. Okay, not that they are supplementary. Okay, supplement theorem links with linear pair. You want to kind of associate keywords with these theorems. So with supplement theorem, you associate linear pair. Okay, so if you ever see linear pair, probably going to use supplement theorem. Definition of congruent segments. This one you will use a lot. Okay? So if I have segment AB congruent to segment CD, then I know AB equals CD. Do you remember the difference between these two statements? This one is your congruency. It's just talking about the segments themselves. This one is talking about their measure or their length. Okay? So when you have it like this, that is the measure or the length. Okay, so if I have segment AB and segment CD, okay, and I was given that they are congruent. Okay, so I'm going to mark them as congruent. Now, if I know AB is equal to 4, okay, AB is equal to 4. So I can label that. Then, CD would be what? Equal to 4. Okay, so it's this definition of congruent segments switches it in between congruency and measure. Okay, so either or. So this can be forward and backward. So if you were given this, their measures are equal, you could also state that their segments are congruent. Okay, so that's what the definition of congruent segments does. Switch it between congruency and equal measures. We have the same thing with angles. Okay, so if you have definition of congruent angles, you're going to switch between congruent angles and equal measures. Okay, with angles, this little m here means the measure of that angle. Okay, so you need to include that. When you're talking about congruency, you don't need to include the m. Okay, so if I have angle A and angle B, okay, we were given that those two angles are congruent, so I'm going to label those congruent. And if I know the measure of angle A is equal to 20 degrees, then I can also state the measure of angle B is equal to 20 degrees. Okay, so since those are congruent, their measures are also equal.
Wait, okay.
Sorry.
No,
There you go.
alright, we do. Why is that?
All right, so there are a couple different things that have to do with right angles and perpendiculars. Okay, there are 3 different things. So the first one here is definition of perpendicular lines. You have another one that is definition of a right angle. And you have the last one that's the right angle theorem. So there are 3 different things that you have to kind of look at to see which one it is. So this first one is definition of perpendicular lines. So you have two lines that meet at a right angle. Okay, so you use this one when you're given two lines. Okay, so you have to be given two lines. Do one vertical, one horizontal here. That meet at a right angle. So they create that right angle. So again, this one, you need two lines. So if you're given two lines that meet at a right angle, you'll use definition of perpendicular lines. The next one is the definition of a right angle. Okay, so if you're given that it is a right angle, you know its measure is 90 degrees. Okay, so if I have an angle, okay, angle A here, and I was told it was a right angle, I can say the measure of that angle is 90 degrees. So definition of a right angle. Given a right angle, its measure is 90. The next one is definition of complementary angles. Okay, those are your two angles that sum to 90 degrees. Okay, so if you're given two angles, stated they're complementary, you can say that you can add them together, they'll equal 90. So if I have this right angle here, an array kind of coming up this way, so I have two angles now. I'll label them 1 and 2. I didn't say that it bisects that angle, okay? But both of those angles together, so the measure of angle 1 plus the measure of angle 2 will equal 90 degrees. Okay, so two angles that add to be 90 is the definition of complementary angles. For definition of supplementary angles, you have to be careful with this one and supplement theorem. Those are the two that people get mixed up with all the time. Supplement theorem has to do with a linear pair. That's why I underlined that key word. Okay? This one is just two angles that add to 180. Okay? So if you remember, we don't need them to be adjacent. Okay? A linear pair has to be adjacent. So if I have angle A is 80 degrees, and I have angle B, and I know angle B was 100, well, if I add those two together, that would be 180, meaning those two angles are supplementary. So I could say that's the supplementary definition of supplementary angles. So if I add angle A plus angle B, I'll get 180 degrees. Any two angles that add to 180 use the definition of supplementary angles. All right. Next, you have, we're almost done. Next, you have segment addition postulate. Okay? Next is the segment addition postulate. So if you remember when we went back, we'll go back to chapter 1. We had a segment and a point between those two endpoints, right? We could add together the two smaller ones, and that equals the larger. That's your segment addition postulate. Okay, so if you're given 2 points, A and C, okay, so I'm going to draw on my segment here. Your endpoints, A and C, and point B lies on that segment between them. Okay. You can take this segment, so that small one, AB, right? You can add on this segment, BC, so the other smaller one there. Okay, and those two added together is AC, the entire segment. Okay? So if you ever have something that states this right here, so if I take that segment AB, add on segment BC, it will equal the entire segment of AC. That's your segment addition postulate.
So, what's our homework gonna be like?
Relax.
Relax.
The next one here is the angle addition postulate. Okay, so it's similar to segment, okay, except this time it's angles. So if I have an angle here, okay, I'm going to split this into two angles. Okay, I'm going to label these, okay, with my points. So I have point A, point B, point C, and I'll label this one with point D. All right. So I can take both of my smaller angles, and if I add those two together, I should get this larger angle here. Okay, so if I take the measure of angle ABD, okay, so that's this first angle right here. Add on the measure of angle DBC. Okay, so that's that second angle there. I should get that entire angle of ABC. Okay, so it's adding your two smaller angles together to get your larger, just like with your segments. Okay, questions on this page? Yeah, the next one is long, but it's stuff you already know. So right angle theorem has to do with right angles. Okay, so this is another one where you may confuse it with definition of perpendicular lines or definition of a right angle. Now, recall this one, you need two lines that form a right angle. With this one, it's just stating if you have a right angle, it's 90 degrees. Over here, you have perpendicular lines that form four right angles. Okay? So if you have four right angles formed, so all four of these are right angles. It's a right angle theorem. Now, this is the part that you're going to use most often. All right angles are congruent to each other since they all equal 90. Okay? So if you have angle 1, angle 2, and angle 3, and angle 4, okay, 1, 2, 3, 4. Okay, if all of those are right angles, okay, they're all congruent to each other. So you can say angle 1 is congruent to angle 2, congruent to angle 3, it's congruent to angle 4, since they're all right. Okay, so all right angles are congruent to each other. Your perpendicular lines form congruent adjacent angles. Okay, what does adjacent mean? Next to. Okay, adjacent means next to. So perpendicular lines, these are perpendicular. They form congruent adjacent angles. They're congruent because both are 90, and they are adjacent because they're next to each other. Next part, if two angles are congruent and supplementary, then each is a right angle. So they're congruent, supplementary, so they add to 180. It'd have to be 90, so they're right angles. If two congruent angles form a linear pair, then they're right angles. Okay, linear pair again looks like this. And if I know that they're already congruent, they have to be 90 degrees, so they have to be right angles. Okay, so this has to do with all of your right angles. But again, you're going to use this theorem mostly when you're saying that those angles are congruent because they're right angles. The last one is the vertical angle theorem. Okay, vertical angles are those two angles across from each other. And this one just states that all vertical angles are congruent. Okay, so vertical angles are always congruent to each other. So if you remember, your vertical angles form an X. So you have two lines that are intersecting, and it's the angles that are across from each other that are congruent. Okay, so if I have angle 1 and 2, angle 1 would be congruent to angle 2. So if you have vertical angles, you always want to look at your picture when you're doing proofs. Okay, look at your picture. Vertical angles are usually going to be one of your freebies. Okay, I call them freebies because you need to look at your picture and put that in your proof. So when you see those, you can say, well, I know those two are congruent because of the vertical angle theorem. Because vertical angles are always congruent. Okay, questions on this? Okay,